So, when you copy down the catalog, some things that I need you to note and realize. First things first, I know this is linear. I know it's a line, but it's going to be called the identity function. So, on your quiz, it's going to ask, your quiz that you have on Friday, I need to write it on the board, but your quiz that you are going to still have on Friday, it's going to ask you to match different things, like the domain, the range, if it's continuous, the graph. And so it's going to say identity. You have to know that when it says identity, it's asking for the linear. Same thing with the square function. What are we used to calling this right here? Parabola. But what kind of function is it? Quadratic. It's not going to be called the quadratic on the quiz. It's going to be called a square function. All right? Because that's the name of the technical name of the function. Okay? So just be careful with these two, because those are the two that people forget. And then don't get constant and identity mixed up. Constant is a flat line. Identity is a slanted line, or not flat line. All right, so just remember lines, absolute value, and parabola all have a domain of all real numbers. And then the range depends on, the constant is just whatever that number is. Y equals 10, it would be 10 for the range. Lines have a range of all real numbers. And then absolute value and the square function both start at 0 and go to infinity. I feel like we should be okay with domain and range. Yes? Okay, continuous. What does it mean to be continuous? You don't pick up your pencil. It does not mean that it goes on forever. Things can go on forever and not be continuous. Continuous is there's no break in your graph. So all of these are continuous because I can draw all of them without picking up my pencil. Okay? End behavior, this is the first time you've ever seen this. So eventually you're going to get to this. We're going to use this as limits. But for now, what end behavior is it's basically asking, how does the end of the graph behave? What's happening? So you are going to be looking at the arrows for end behavior. Look to the left and look to the right. So this one's a little bit weird. But to the left, as this graph is going to the left, what's happening for my y values? They're going down. So as x approaches negative infinity, y is going to negative infinity. They're both going down. And then as it's going to the right, positive infinity for x, what is y doing? Going positive infinity. Okay? For absolute value, as it's going to the left, what is it doing for the y values? Going up. So x is approaching negative infinity, y is approaching infinity, going up. And then to the right, as x is approaching infinity, what is y doing? It's going up again, so y is also approaching infinity there. All right, and so that is what end behavior is. It's just describing what your arrows are doing as it's going to the left and going to the right. Does that now make more sense to you? Okay? Even and odd we talked about all day yesterday. So as a reminder, even means it's symmetric about the... Even is symmetric about the y-axis, which is why this one, and this one are even. They're reflected over the y. Odd is symmetric about the origin. So if I turn my paper over, do you agree that is rotate 180? That's the same exact picture. And same thing for the cubic function. It's the same picture. All right? At the very end of class, I very briefly talked about increasing and decreasing. Something I want to mention. Can y'all look up, please, at my picture? You don't have to write this down, but just look up. People often get parabolas increase and decreasing wrong. Why? Because what do I have? 2 arrows going up. So people are like, oh, it's increasing this way and it's increasing this way. But why is that wrong? You have to read it left to right. I get that this arrow is going up. But if you start to the left, you're drawing it going down. Does that make sense? So just be careful. That's what this increasing and decreasing is over here. Same thing for the absolute value. I got it. It looks like it's going up, right? But actually, if you're reading from left, it's going down, then turning and going up. So it does have both intervals of increasing and decreasing. Also, increasing and decreasing, remember, always need parentheses. There's not going to be, these are not points. Somebody First period was like, Miss Alvarez, why are you writing points? These aren't points, these are intervals. We're never going to have brackets though, because you're not actually increasing at a point. It's just a point right there. Do I have any question on the front of this catalog? What if you happen to not do this last night? It's still in the folder. Go do it tonight. Okay? All right. Turn your paper over. You should have also copied the back. The back is a little bit more complex. There was a back. So again, if you didn't do that, you are going to, it's in the folder. Do that tonight.
Miss, that's clickbait. Look, that is clickbait.
There was 2 pages on the thing.
If you got the remind, I literally said page 5 and 6. Didn't I?
Miss, you kicked me out of the remind.
I don't kick anybody out of the remind.
I
don't kick people out. All right. Principal square root is just the square root function. As a reminder, the domain is not all real numbers because it starts at the origin. All right. And so because of that, it only has one arrow. You're only going to have one end behavior. This is only increasing, and it's not even or odd. It does not reflect across the y-axis. And if I turn this and rotate 180, is that the exact same picture? No. So that one would be neither. Cube root is basically if you take the cube function and turn it. Rational, there are 2 rational. So I'm going to refer to this one as the odd rational and this one as the even rational. And that's how, like when I ask you questions, you're going to differentiate what I'm asking for. So if I'm talking about the odd rational function, I'm talking about 1 over x. If I'm talking about the even rational function, I'm talking about 1 over x squared. Remember, rational functions have asymptotes. How can we find this asymptote, or how can we find where the domain is, where the restriction will be? Set, what'd you say? Look at the denominator, set it equal to 0, or not equal to 0. Okay. These are not continuous because they have asymptotes. Do I have any questions about this? We're okay? All right, and then the last one, which, how many of y'all have already taken college algebra? 1, 2, 3, like not right now, not currently, but like you've completed the whole class of college algebra. Okay, only a couple of you. How many are currently in college algebra right now? Okay, so a good amount of y'all. So you're probably going to find we're about a day off. I think y'all learned piecewise functions last week, I heard. We're going to do that tomorrow. We're learning greatest integer today. I think y'all are doing that tomorrow. So we're kind of on the thing. But this is the greatest integer function. When I graphed this, I chose, because this graph is so tiny, I basically said every unit was 0.5. So I know this goes 2 units, but it really goes only 1 unit. Okay. Some things to know about greatest integer is it starts at 0, 0, and it's also called the step function. So it's a constant, and then it has a hole at the end of the step. Why does it have a hole at the end of the step? It's so it passes the vertical line test. This is a function because one's a hole and one's a point. Does that make sense? And then it steps up. I know, again, this is 2 squares, but it's 1 unit. And then there's a point, and it goes over a unit, step with a hole. Go up, over a unit, step with a hole. So in Desmos, you can graph this by doing y equals floor x. But it doesn't graph, I don't think it graphs the holes. So just be aware. That's just what Google told me. So just letting you know. And you can see the different, we're going to look today, but the different transformations and what happens with it. Okay? But this is the greatest integer function. Again, step function is like a nickname. It is all real numbers. The x values are all real numbers. Again, because of that hole, it just hits every single x value. However, the y's because it steps up. The y's are only at integers. At 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Because it skips all those decimals. It's obviously not continuous because you have to pick up your pencil. And it's still, I know there's no arrows in this function, but it still has end behavior because as you keep going left, what happens to your y's? They go down. And as you keep going right, what's happening to your y's? It's going up. Why is this not odd? Because if I rotate this 180, isn't that the same picture you have on your paper? Why is it not odd? Because the holes are in a different spot. Do you agree your holes are now to the left? Okay, also this very first step should go to the right. So you see how the first step at the origin goes to the right. All right, and then it has only constants. And the constants are in between all your integers. Okay? Do I have any questions about this catalog? If you didn't write it down, you're still responsible for writing this down, referencing it. I now need you to go to the next page. Now we're going to graph. Page 7, please. Oh, yeah. Okay. Transformations is what we are going to do today. Transformations. We are going to do 6 different functions as we're doing these. But no, these can be applied to any function. So number 1 is going to be f of x equals x plus 2 squared minus 1. What function, or what is the parent function of this? The square function. Which is y equals x squared. I am going to sketch the parent function on my graph every single time just so y'all can see it. I'm not going to connect it or anything. I'm just going to plot the points. So the square function y equals x squared. What shape is that? A parabola that starts at 0, 0. So I'm going to plot 0, 0. What's 1 squared? 1, 1. What's 2 squared? 2, 1, 2, 3, 4. And 3 squared. And then negative 1 squared, negative 2 squared, and negative 3 squared. Again, I'm not connecting them. I am just plotting those points of the parent function. What transformation do we see? We are going to go left 2. Why left 2? Because it's positive, and in the parentheses you always do the opposite. And we are going to go down 1. So y'all, take every point and left 2, down 1. Go. Oh, I'm so sorry. I meant to introduce you and I just started going. This is Mr. Smith in the back. If y'all just want to say hi. My bad. Mr. Smith is not going to school. He already went to school. Training? Is that how we? In a program to become a teacher. So he's going to be observing in here every once in a while. He will be walking around, asking you questions, asking to help, because that is what the requirements of his training are. Do you have anything to add? I'm so sorry.
No.
I meant to do that right away, but I forgot. Alright, so if he walks around and asks you a question, don't be shy. And feel free to walk around now if you want. You can ask him questions, yes. I don't know if he knows the answer, but maybe.
I don't even know what
I will count off if you don't have arrows. However, I am not as picky as some teachers. If you don't go off the graph, I don't make a big deal about it. However, if you cut your graph off right here, I will count off points. Does that make sense? Like, make a full parabola. A lot of the times, the rule of thumb I would go by if I were you is 5 points. If you can fit 5 points, do 5 points. Honestly, do as many points as the graph will allow, but can I move on? Are we okay with this? Cool. Example 2. F of x equals 1/2 the square root of x minus 1. What function is this? It is the square root function, which is what? Is the parent function. Y equals the square root of x. And now I am going to plot the parent function. What's the square root of 0? Square root of 1? Do you know the square root of 2 or the square root of 3? So I'm not going to plot those points. What's the square root of 4? And then what's the next one that we know? The square root of 9 is? That is the parent function. That makes sense? What now? What 1/2? And what kind of compress? It is a vertical compression by 1/2. And why right? Because we do the opposite. If it's next to x, we're doing the opposite. So we're going to go right 1. When we vertically compress, we are multiplying our y value. Vertical is the y. So I'm going to basically look at all these y's and do half of what they are. So what's half of 0? 0. Stay 0, and then just go right 1. The next one is at 1. What's half of 1? Half, and then go right 1. Half of 2, and go right 1. Half of 3, 1.5, and then go right 1. Oh my goodness. Again, I just took the y values and then multiplied whatever that y value was by half. How did I know this was a vertical compression and not a horizontal compression? Because it's outside of the root. If it's inside with the x, it would be horizontal. Honestly, I don't think we're going to be doing very many horizontal. Edwin, get off your computer. You don't need it. Boy, don't make me take it away. What questions do I have? Can I move on? You do the next one on your own. I'm going to give you 3 minutes. Go. No. I got 3 more after that. It is f of x equals negative x cubed plus 1.
Oh my God, that's really good. How old are you? How old are you? Because think when you do negative x squared, you're flipping it. I got left.
Yes, correct, correct.
I don't think I've heard this one. I don't think I've heard Ah! I'm cooked. Wait, don't trip. Yo, what? Don't wind it up yet.
What kind of reflection is that?
I told you.
Is it a vertical or horizontal?
But it's negative. It's horizontal.
It's horizontal, and if you're horizontally reflecting, you're reflecting over the
Why? So why axis? I mean, it's the same thing though.
It's a vertical translation or whatever. No. It's horizontal looking down right. Good job, bro. Thank you, gang. I appreciate it. Could have done without me. Preach. Great.
Perfect. Thank you. Yeah. A horizontal reflection over the y-axis. What's the other? Up one. And did y'all write that it's a cube function? Oh, I need to do the parent function. Hold on.
No, I did. I wrote plus 3 instead. No wonder my job was one thing above the one.
All right, look up to make sure that you got this right. You got it right? Good job. Okay, pause real quick because I meant to say this earlier, but I forgot. This right here, the cube function, it is not flat right there. So please make sure, y'all have a tendency when you're graphing the cube function to kind of go like this. Or like make it is not flat right there. So just make sure you don't have like a flat line. Okay? All right. Are you ready for more? Can I change this? Okay. Example number 4 is f of x equals negative absolute value of x plus 2 plus 3. But you can do complicated. What is this parent? We're going to do this one together. What is this parent function? The absolute value. How do you graph that parent function? A v starting where?
0, 0.
0, 0. And then from there, I need that in black. From there, what do we do? 1, 1, 2, 2. Because what's the absolute value of 1? Absolute value of 2. Absolute value of 3. So it just kind of goes a slope of 1. This is a really good, hold on y'all. This is a really good example of, don't just do 5 points on this one. You do 5 points on this one, I will count points off. That's way too small. Do as much as you can. It is. I agree. But you could do like 1, 1, 10, 10. Connect them. You know what I mean? What are the transformations here? What kind of reflection? A vertical reflection. over the x-axis. What else? Left 2, and then what do you say? Up 3. So I'm going to take each point reflected over the x-axis and then go left 2, up 3. And then you're going to kind of notice it's just what? What's my slope here? What questions do I have? Anything? I don't want to shut your computer. I know, but shut it. Nicole, same thing. I'm going to start taking them up. Alright, we're going to do a greatest integer function. So I'm going to graph the parent function. It starts with a point at 0, 0, goes one step, and then a hole at the next unit. From that hole, go up 1, draw another point, step, make a hole. From that one, go 1 up, make a point, step, hole. And that's as far as I'm going to go on this one. I'm going to go backwards too. Again, we could sit here all day and do the parent function. We're just not going to, just to not clutter up our graph. But does everybody see how the integer function goes? Greatest integer function goes. So what, let me write that down, right? This is the greatest integer. What transformations are happening here? Louder? Vertical stretch times 3. We're going to multiply our y values by 3. And we are going to do what?
Right 2.
We're going to go right 2 units. Bless you. Okay, I want you all to look up as we do this real quick. Look up just real quick. For this, I'm going to start off with my 0, 0. If I multiply that by 3, I still get 0. And then I need to do what? Right 1, 2. So that's going to be where my point is. Step, make a hole. Watch again. My point 0, 0, multiply it by 3, still 0, and then go right 2. Now for this point, 1, 1, I'm multiplying my y. What is 1 times 3? So I'm going to go 1, 2, 3, and then what do I need to do? Right 1, 2. Do you see how this changes my step from just going right a step, up a step, right a step, up a step, to now it's going up 1, 2, 3 steps. Right a step. So now I'm going to go up 1, 2, 3 steps. Make a hole. 1, 2, 3 steps. Slide, make your hole. Up 1, 2, 3 steps. Slide, make your hole. And you can do the same thing going backwards. Go down 1, 2, 3 steps. 1, 2, 3 steps. What questions do I have about the greatest integer function? It's a little weird. Yeah. Thank you. Now, what if this was a vertical stretch? No, it is a vertical stretch. What if this was a horizontal stretch? My steps would be longer. So a vertical stretch makes it steeper to step up. A horizontal stretch, if the 3 was inside, the step would grow 3 units instead of just being 1 unit. Does that make sense? Okay. Again, because the notes don't have it, I don't think we're going to have a lot of horizontal compressions and stretches. All right, you're going to do this last one on your own. Ooh, do we want it? Let's try it. You got it? It is going to be rational. I would not draw the parent function to this one. My actual advice on this one is going to be make a table and plug in points. Let me let you struggle through this one. 2 over x plus 1. Let's see what you got. Make a table. Yeah. Plug them in.
X can equal to
Which rational?
This is the diagram. Make a table, plug in points to figure out where to plot them. Can you find the asymptote?
Okay, so you start right here. It's right there. The top one right there.
Is it just negative?
Yes, the top one right there.
Now, as it was, what's the what? Yeah, what does that do? Stop, don't do it. Well, what do you think it does? What's the parent function? Are we struggling good or struggling not good?
It's not a reflection. I think it's like a vertical.
You ready for me? Okay. What if I rewrote this? Because the parent function is this is rational. Do y'all agree? The parent function is 1 over x. So could I rewrite this as 2 times 1 over x plus 1? So what does that 2 do? It's a vertical stretch times 2. Okay? And what is this x plus 1 going to do? It's with x, so what am I going to do? Left 1. Now I'm going to be honest. Again, rational functions just aren't the easiest thing to deal with. So I also here make a table. Normally, for rational functions, for the parent functions, your asymptotes are on the x and y axis. Do y'all agree with that? So if I'm going left 1, where is my asymptote going to be at? Also, if you didn't know that, we went left 1. How do you know where the asymptote's going to be at? The denominator. What can you not divide by? 0. So what can x not be? So I'm going to draw an asymptote at x equals -1. Did this shift up or down at all? So my asymptote's going to be on the x-axis. Okay. Where's everything else? I don't know. So I'm just going to start plotting points. You honestly can choose any number. You could sit here and do -10, -9, I'm not going to do all that. So I'm going to do, let's do -3, -2, -1, 0, 1, and 2. Really, I need 5 points. If you do more, that's great. Don't do less. The only time you can do less is like right here, where there are 5 points even on the graph. No, there were only 4. I'd accept that. But if you can do 5, I need you to do at least 5. All right, -3. If I plug that in here, what is -3 plus 1? What is 2 divided by -2? So I'm going to plot -1, 2, 3, -1. Plug in -2. What's -2 plus 1? What is 2 divided by -1? So plot -2, -2. What about -1? What is -1 plus 1? What is 2 divided by 0? Undefined, which is why we have that's why we have an asymptote right there. And hey, that's all we can really do here. So I can just draw that. You don't need 5 points on each part. You need 5 points for the whole graph. Plug in 0. 0 plus 1 is, what's 2 divided by 1? 2. And then plug in 1. 1 plus 1 is, 2 divided by 2 is, and then the next one is going to be 2 plus 1 is, 2 divided by 3 is 2/3. So I'm just going to plot it somewhere right there. Do I have my 5 points? We're good. Let me zoom out for y'all. Does this make sense? Do you think you would have been able to graph this rational function without a table? Maybe. Maybe you could have done the table in your head, sure. And that goes to say, you could do a table for any of these if you get confused. If you're unsure what to do, make a table every time. It'll work. Okay? All right. For the rest of class, which we have about 10 minutes, you need to get started. Do I have any questions before I move on? Nicole? I am. You have homework due on Friday. Originally it was Thursday, but originally we were going to have a homework day tomorrow, essentially. It's supposed to be today, but blah, blah, blah. We aren't going to do that anymore because we missed Monday. So we're still going to do piecewise tomorrow, and we're still going to do quiz A on Friday, but your homework is not due till Friday. I want you to get started on it. I need you to use graph paper because you will be graphing. But I also want to show you something real quick about it. If you look at, especially page 40, when you look at the problems for page 40, it's very hard to see. This is asking about increasing, decreasing. Do y'all agree it's very hard to see what this is? My advice is it's homework. You aren't going to have a problem that looks like this, that hard to read on your test. But my advice is to type this equation in Desmos and actually go click the points to see where it turns so you're right and you're increasing and decreasing for x values. Does that make sense? All right, so for page 40, please use Desmos on this one and this one. You will not get Desmos on any quiz or test, but for that one, just because the pictures are so bad, I would put that in Desmos so you can see. All right, you have the rest of the class period. You need to everybody has to start homework. Let's go.